Now students, let us see exercise 1.1. Find the 5 rational numbers between 1 and 2. Find the 5 rational numbers between 1 and 2. So now let us follow the one step method, easiest method. So here we have the number of rational numbers 5. Then immediately find n plus 1, that is 5 plus 1 is equal to 6. So first take the 1 and multiply it by 6. 1 into numerator and denominator, that is 1 nothing but we can write it as 1 by 1, that is 1 into 6 by 1 into 6, that is simply we can write it as 6 by 6. And again the next number 2, and it can be written as 2 by 1 multiplied by again 6 and numerator and denominator, that is 2 into 6, 12 by 6. So what we have here, 6 by 6, that is nothing but 1, and 12 by 6, that is nothing but 2. Now after 6 by 6 we can write immediately 7 by 6, and then 8 by 6, 9 by 6, 10 by 6, 11 by 6, and then 12 by 6, that is equal to 2. So let us count after 6 by 6 how many rational numbers are there. 1, 2, 3, 4, 5. Okay, after 6 by 6, before 12 by 6, we have these 5 rational numbers. Okay, in this way we can easily find. So this is the easiest sum. Now students, let us see the next one. Second sum. Find 3 rational numbers between 3 by 5 and 2 by 3. So here we have the fractions. So to get, so we have here 2 fractions, 3 by 5 and 2 by 3. So now take the 2 fractions first of all. Now make them into similar fractions. That means the denominator should be same. So here to get the similar fractions, take the LCM of 5, 3. So these two are prime numbers, so that's why we can directly write the product of that numbers, which gives us the LCM, that is 5, 3 is 15. Now here first of all write 3 by 5. So now make the 5 as 15. To make 5 15, we have to multiply numerator and denominator by 3. That is 3 3 is 9, 5 3 is 15. And in a similar way 2 by 3. Make 3 as 15. So we need here 5 because 3 5 is 15. So multiply 5. So 2 5 is 10, 3 5 is 15. Just simply concentrate on the denominator. Okay. So here we have already 5, that's why we multiply with 3, and we have here 3, so that's why we multiply with 5. So by that way we got here 9 by 15, 10 by 15, which are consecutive fractions. So in between these two rational numbers, we have to find 3 rational numbers. Again follow that one step method. So for that we need again the same process. So let us take n is equal to 3, then immediately find n plus 1, that is gives us 3 plus 1 is equal to 4. So again take that 9 by 15 and multiply this 9 by 15 by 4, that is simply you get 9 4 is 36, 15 4 is 60. Simple way. And again 10 by 15, and here also multiply by 4 on numerator and denominator, we get simply 40 by 60. Then write the fractions. 36 by 60 first fraction, that is 9 by 15, that is nothing but 3 by 5, and after 36 by 16 you can write easily 37 by 60, and the next 38 by 60, and the next 39 by 60, and the next 40 by 60. Okay, so in this way we can find easily the three fractions or rational numbers in between these two given rational numbers, 3 by 5 and 2 by 3. 36 by 6 nothing but 3 by 5, 40 by 6 nothing but 2 by 3. In between them we got these three fractions. So like this way we can easily find the number of rational numbers. Okay, now here, now let us take the representation of rational numbers on a number line. Already we learned in previous videos. I hope that you can understand that the type of sums. Now let us see again. Now let us see, students, represent 8 by 5 and minus 8 by 5 on a number line. Okay, already we learned in the previous video also. So once again let us see that these type of sums. Okay, see, now here we have the 8 by 5. So what type of fraction is this? Yes, it is a improper fraction. So why here numerator is greater than that of the denominator? So easily we can make it as a mixed fraction. That means here in this 8 we have 5, nothing but we can write 5 plus 3 by 5. How can we write? Here observe the denominator 5. So in this 5 we can, in this 8 we can write 5 plus 3, that is in this 8 we can write it as 5 plus 3 by 5, and then we can split it as into 5 by 5 plus 3 by 5. So you can easily convert it as into 1 plus 3 by 5, that means one integer 3 by 5 which is greater than 1. That means we have to represent this 8 by 5 on number line after 1. And in a similar way, minus 8 by 5, it is also on left side to 0, that is also we can write so already is minus as it is 5 plus 3 by 5, that is minus 5 by 5 plus 3 by 5. So we can make it as minus 1 plus 3 by 5. It is left side to 1. That is here to represent these two fractions on number line, we need a number line. Try a number line like this and keep 0. Now on right side we have the post numbers. So here we have to write the first of all 1 and 2. So but actually we have here in denominator 5. Okay, so that's why each unit, here we have 0 to 1 1 unit and 1 to 2 other unit. So these each unit can be divided into 5 equal parts. So to get 5 equal parts we need to point out 4 points, that is here 1 2 3 4, which are equidistant to each other. So that's why here we have how many parts? Count them: 1 2 3 4 5. Okay, that means after 0 up to here we have simply 1 by 5. Okay, and the next second 2 by 5, and next third 3 by 5, and the next fourth 4 by 5, and easily you can write this 5 by 5 is nothing but 1. Okay, so like this you can represent the fractions on a number line. Okay, by saying what? Concentrate on the denominator, by concentrating on the denominator. Now again in between 1 and 2 again we have to make this unit into 5 equal parts. For that again we need here 4 points. Okay, so here again count the parts, equal parts in between 1 and 2: 1 2 3 4 5. So after 5 by 5 we can get easily as it is 6 by 5. Okay, continuously you write like that only. Again 7 by 5 and next 8 by 5, 9 by 5, this 2 nothing but simply what, 10 by 5. So but we need here what, 8 by 5, this number. So this is located at here. That means it is in between, that is it is lies in between 1 and 2. Okay, so like this we can easily represent the 8 by 5 on number line. Okay, so next on left side, again here to 0 just keep the 2 units, -1 and -2. Why 2 units only? Here the 8 by 5 is located after 1 and here also -8 by 5 is located -1 after -1. So that's why we are taking only 2 units. And again 0 to -1 equated into equated into 5 equal parts, that is divided into 5 equal parts. Again for that we need 4 points, 1 2 3 4. Okay, and again here after 0 we can write it as -1 by 5 and next -2 by 5, next -3 by 5, -4 by 5, this one is simply -5 by 5 till here over. Next -1, after -5 by 5 we can write it as, keep the 4 points in between -1 and -2. So now again here after -5 by 5 you can write -6 by 5, -7 by 5, -8 by 5, -9 by 5, this 10 minus nothing but -10 by 5. So here we got -8 by 5. So like that we can easily represent the fractions on a number line. So do practice well these type of sums. Okay, next. Now the next topic is decimal form. Already we learned in the lower classes. Once again we recall that decimal forms. So here I am taking one example. So express 7 by 16, 2 by 3, 10 by 7 in decimal form. So to do these sums we must know about the division. Already you know. So now here first you take the 7 by 16, divided 7 by 16. So as you all know, 16 is a bigger one, 7 is a smaller one. So to divide this we have to keep the decimal. That means here we have to write 0 point. So after writing a 0 point, just keep here 0 beside to 7. Now it is bigger than that of the 16. As you know this process already. Now 70, divide 70 by 16. So in how many times it will go? 16 fours are. Okay, you must know the tables up to 20 at least. So 16 fours are 64. Now minus 70 minus 64, 6. And again already here we have the decimal, so keep 0 and again divide it again by 16. So 60 it will go in how many times? 16 threes are, yes, 16 threes are 48 and again minus, here we get 12, already point is there, 0, 120. Now again 16 6s are 7s are, 16 7s are, we get here 112. So after minus we get 8, point is already there, 0, that is 16 5s are 80. Okay, so like that you can get the 7 by 16 is equal to 0.4375. Okay, that means after decimal we got 0 as reminder after some decimal places. That means this type of decimal is known as what? Terminating decimal. Okay, if you observe these words, terminating decimal. And again go for 2 by 3. So divide 2 by 3, and again the same process, keep here 0 point, we get here 20. Now 3 6 are 18, 20 minus 18 2, again 0, 3 6 are 18, remainder 2, and again 0, 3 6 are 18 2. So it is goes on. That means here the 2 by 3 is equal to 0.666 up to so on. Otherwise we can write it as 0.6 bar. Why? Because here 6 is repeating so many times. That's why it is known as a repeating decimal or non-terminating decimal, or otherwise we can write it as a recurring decimal, non-terminating recurring decimal. It is also perfectly known as non-terminating recurring decimal, non-terminating recurring decimal. So please observe the words I am writing here, what I am writing. So see, please observe carefully. Now again the third fraction, 10 by 7. So in this 10 by 7 also we have to divide 10 by 7 table. Let us see. By 7 table, 7 ones are 7, 10 minus 7 3. Okay, so keep your point. So 30, 7, no, in how many times 30 it will go by 4 times. 7 4s are 28. Again here 2 remainder, point is also there, 20, and again 7 2s are 14. 20 minus 14 6, already point is there, 0. 7 8s are 26, 4, already point is there, 0. 7 5s are 35, 40 minus 35 5, already point is there, 0. 7 7s are 49, and again we got here 1, already point is there, 0. 7 1s are 7 3, like that. So here it is 1 point, that means here 10 by 7 is nothing but we got 1.428571, that is, it is also not terminated, non-terminating. So that's why here we can write it as, this decimal is particularly non-terminating, non-recurring decimal. It is known as non-terminating, non-recurring decimal. So these are the 3 types of decimals. Okay, please observe carefully this one. This concept is very useful to the further concepts. Okay, next.